Hi everyone, welcome to our lesson on storage devices. Today we'll explore the different types of storage used in computers and their specific roles. By the end of this video, you'll have a solid understanding of how these devices work and why they're essential for your computer's performance. Our main goal for today is to explain the characteristics and uses of RAM and ROM, understand the concept of virtual storage, and discuss the various types of storage devices, including magnetic, flash, and optical storage. Let's dive in. Before we get into the details, let's think about what we already know about memory. Memory in a computer is crucial for storing and accessing data quickly. We have main memory, which includes RAM, and secondary storage, like hard drives and SSDs. The CPU, or central processing unit, processes data while input and output devices help us interact with the computer. There are two primary types of memory in computers: RAM and ROM. RAM, or random access memory, is used for temporary storage of data that the CPU needs to access quickly. ROM, or read only memory, stores essential instructions that the computer needs to start up. RAM is like your computer's short term memory. It holds data that is actively being used or processed. On the other hand, ROM is like a reference book that contains critical information your computer needs to boot up and function properly. Let's compare RAM and ROM. RAM is volatile, meaning it loses its data when the power is turned off. It's used for tasks that require quick access to data. ROM, however, is non-volatile and it retains its data even when the power is off. It's used to store firmware and other essential instructions. RAM can be read from and written to very quickly. At any given time, it typically contains the operating system, the software you're currently using, and the data that software is processing. This makes RAM crucial for your computer's performance. ROM is special because it holds data permanently, even without power. This is essential for storing the instructions your computer needs to execute immediately when you turn it on, like the BIOS or firmware. When your computer is on, it stores running programs and data in RAM. This allows for quick access and smooth operation. However, when the computer is off, RAM is empty because it is volatile. When you start your computer, the operating system is loaded from the hard disk into RAM. This process is essential for managing hardware and software resources, allowing you to interact with your computer. Applications and documents are loaded into RAM from secondary storage when you use them. This makes them readily accessible and speeds up your workflow. For example, when you open a word processor, the program and the document you're working on are loaded into RAM. But what happens when you try to open more applications than your RAM can handle? If your RAM is full, your computer might slow down or start using virtual memory to compensate. Virtual memory is a portion of your hard drive that acts as an extension of RAM. While it increases available memory, it's slower than physical RAM. This can help you when you're running many applications, but it's not as efficient as having more RAM. When all available memory is used up, your computer's performance can suffer. It might slow down significantly, and you may experience delays or crashes. Now, let's talk about different types of storage. Primary storage, like RAM, is volatile and used for active processes. Secondary storage, such as hard disks, SSDs, and optical media, is non volatile and used for long term data storage. Secondary storage technologies include magnetic storage, like hard disks, optical storage, like CDs and DVDs, and solid state storage, like SSDs and USB flash drives. Each has its own advantages and disadvantages in terms of durability, speed, capacity, portability, and cost. Hard disks store data on spinning platters with magnetic surfaces. Data is organized into tracks and sectors, and read write heads access the data as the platters spin. Hard disks offer high capacity and fast read write speeds, making them ideal for storing large amounts of data. Cloud storage allows you to store data on remote servers accessed via the internet. It's scalable, secure, and accessible from anywhere, making it a popular choice for backups and file sharing. SSDs are flash memory to store data, offering faster access times and greater durability than hard disks. They have no moving parts, which makes them more reliable and energy efficient. However, they are typically more expensive and have less capacity than hard disks. SSDs are more durable because they can withstand physical shocks and extreme conditions. They also provide faster read write speeds, consume less power, and are more portable. However, they usually have a lower capacity and higher cost compared to hard disks. USB flash drives are portable storage devices that can store up to 128 gigabytes or more. They're affordable, easy to carry, and can use password protection for security. They're great for transferring data between computers. In military applications, storage media must be durable, reliable, and secure. SSDs are often used because they can withstand harsh conditions and maintain data integrity, making them ideal for field use. Optical discs, like CDs, DVDs, and Blu ray discs, have different capacities despite being the same physical size. This is due to different laser wavelengths and data encoding methods. For example, a Blu ray disc can store full length HD movie or videos, while a CD can store music or software. Optical discs come in three formats: read only, recordable, and rewritable. Read only discs, like CD ROMs, cannot be modified. Recordable discs, like CDRs, can be written to once. Rewritable discs, like CDRWs, can be written and erased multiple times. Optical discs are cost effective for distributing software. They're cheap to produce, robust during transport, and lightweight. This makes them ideal for distributing installation media. CDs come in three formats: CD-ROM for read-only data, CDR for recordable data, and CDRW for rewritable data. Each format has its own uses, such as software distribution, data backups, and file transfers. CD-ROMs are widely used for software distribution. CDRs are used for copying games, software, audio, or video files. CDRWs are used for short or medium term backups and transferring files. DVDs and Blu ray discs are used for high capacity storage, such as movies. Let's compare different storage media in terms of capacity and access speed. Hard disks offer large capacities and fast access. CD-ROMs have medium capacity and access speed. DVDs and Blu ray discs offer higher capacities. SSDs provide very fast access speeds but typically have lower capacities compared to hard disks. To wrap up, we've covered the uses of RAM and ROM, the concept of virtual storage, and compared different storage devices like hard disk drives and SSDs. We've also discussed the applications of optical disks. Understanding these storage devices is crucial for managing data effectively in computer systems. That's all for today's lesson. I hope you found this helpful. I'll see you again next time. Bye for now.